All right, pumped. Here's what we got to do. We have to figure out the thickness of that aluminum foil. Now, you all know that there are, I said earlier, 2 ways we're going to be able to get that. I want you to do the math for both of these methods. All right, way number 1 is using a little bit of density to help us out. So let's go ahead and take a look at that method. Density equals mass divided by volume. With me so far? All right. That's one way using the density. The second way is going to use the idea that volume is equal to length times width times height. You know that. If you want to get the volume of something, you can measure its length, width, and height. And of course, this is a nice regular shape, except for that one ragged edge I left. It's nice and regular shape because we had a rectangle, so that's a nice regular shape. So volume is length times width times height. So actually, let's take a look at this method right here, because I'm going to go ahead and use this method in here and see how this works out for me. We had this one is displacement. Okay, I'll write this down. We did some displacement. Be clear about that. There are 2 methods. This one is using the displacement method. This one's going to use the density method. So there are 2 ways to calculate the thickness. All right, we'll call it the height, because remember I said length, width, and height. We have a length measurement, we had a width measurement, and a height measurement, which is how thick it is. It's the same thing, so height measurement, thick, same thing. So I want to get the height measurement. So solve for this one. All right, can you see it? Can you see it? Yeah, this one's the quickest and easiest one to see, I believe. I only think so, because we got the displacement volume. Well, technically we didn't get it yet, because we'd have to subtract those 2 values. These 2 values here, right there, graduated cylinder volume before and after. So go ahead and subtract those, and you will get the volume for that aluminum foil. You also know the length of the aluminum foil. You know that we wrote that down as 52.9 centimeters. Let's leave it in centimeters for now. It's okay. We'll go ahead and leave it in centimeters. So 52.9 centimeters. Oh, okay, I'll put the units in. And I'll show you, okay, I'll put the units in because I'm going to show you what happens to the units. Centimeters times the width, which is right on that aluminum foil. That is 30.4 centimeters times height, or the thickness, which is what I'm trying to find, and the volume. Subtract those 2 values. What did you get? 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 72 point. I'm actually doing the math here. I should be doing this in my head. That was Mrs. Weimar would not be happy with me. I did that on a calculator. What the heck? All right, but I got 4.2, and hopefully so did you, partner. So we've got 4.2, and remember, this is milliliters. Okay, milliliters. That's 4.2 milliliters of displacement. But remember what a milliliter is equal to. Cubic centimeters. Yes, very good, Billy. So 4.2 cubic centimeters. All right. And oh, I forgot to put the unit in for the 30.4. That was in centimeters. Centimeters times height. Can you see it? Can you see it? Can you see it? We're going to get the thickness just simply by dividing. Multiply these 2 together, then divide. Now, what happens is 2 of these centimeters will cancel out with 2 of these centimeters, leaving you with 1 centimeter, which is we should get because it's the thickness. So you should be able to get the thickness in centimeters, and that's important. We've got to remember that it's going to be in centimeters, and when we do a further calculation, we need to remember that's in centimeters. So go ahead, divide, get your answer. I don't know what the answer is. I haven't done it out yet. Doggone it. Go ahead and do it. Do it. Do it. All right, it's going to be a small number because remember a centimeter. Where's my meter stick? Well, we'll use this back there, but go ahead and use this bad Larry right here. This is a centimeter. Okay, one of those on the top. And that foil is a heck of a lot smaller than that. So yeah, you should get a small number. All right, this should be point blah, 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 or 10 to the negative blah. Negative, because it's going to be very thin. So that is one method of getting the thickness or the height of that aluminum foil. So that's the water displacement method that we did together. And we done good. All right, now the density method. Using density, I can also calculate the thickness. So we're going to go ahead and use mass and density. The density is given on the sheety thing. That's on the sheet. Remember I showed that earlier. 2.6989. 2.6989. So 2.6989. 2.6989 equals mass, which we wrote down. What do we get? 7.263 grams equals 7.263 grams divided by volume. Okay. So, and the thickness is hidden in here, just like it was down here. So the thickness is in here. So let's go ahead and solve for that V first. We'll solve for V. So I'm going to switch these. I'm going to move the V over. Your algebra teacher wouldn't like me to say that you're just switching those, but that's what we're going to do. You just take the switch, bring the V up here and take the 2.6989 down here. Or another way of saying it is you would multiply both sides by V, divide both sides by 2.6989. Algebra teacher would like that better. But you're just moving these from here to there. And that gives you the volume. So when you divide this out, the 7 point blah blah times 3 point blah blah, you'll get the volume of it. And then once you get the volume of it, you have the length and the width. Because remember, we measured those already. So you are going to set this answer, whatever you get for this answer, so you're going to get some number, blah, 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 and then set that equal to length times width times height, and then go ahead and once again solve for that h. Okay, so this one used the water displacement, that 4.2 cubic centimeters, and this one's going to head and use the volume is going to be calculated by taking this and dividing it by that. All right, this volume here, I'll go ahead and we'll calculate this out together to get the volume up there. 7.263, 7.263 divided by 2.6989 comes out to be 2.691 for a volume on that. All right, now you're going to probably say to yourself, man, the volume came out a lot different here than it did with the water displacement method, right? I mean, because one had a volume, what do we get for a 4.2 versus, I just said it, 2.7. Okay, oh man, that's a big difference, right? That's a big difference. So yeah, it's a big difference, but you're talking about little differences making big differences. And now water displacement method can be a little tricky when it comes to getting the thickness of this. But we'll see which one comes out to be better, because there is a % error to be done with this, and that's in the next video.